Hey, everybody. Everybody hear me? All right. It's a small room, so I'd expect you can. All right. So let me start my clock here. I'm watching the clock. So, all right. Anyway, let me introduce myself. My name is Alex. I used to be a full stack Python developer, like a software engineer. I kind of worked in the trenches in Django, so I earned my Python stripes that way. I like Django though, no hard feelings. These days, I work on the foundation engineering team here at Zendesk, and it mostly resembles what you think of as like DevOps. We're kind of just there to automate the things that are like a house, like the foundation of a house. It's like underneath. What is that? Extent. All right. Sorry about my VPN. So we work on the foundation engineering team. We're kind of like underneath all the apps. So I mean, long story short, a lot of our work kind of hits up against Amazon. So I mean, I don't get to write like Django these days, but we still use a lot of Python day to day. There's lambdas, there's Photo3, because in DevOps, like at scale, Amazon has a web interface that you can click around and just create things at will. But you're probably not going to be doing that. DevOps is all about infrastructure as code. You want things portable. You want visibility. So anyway, but let me show you a project that I made. So and just in case I see a couple laptops, just in case like you're tempted to take notes as you go, everything will be on GitHub later. So don't worry about it. I have an advantage too. I wrote all the code ahead of time. So if you try to keep up with me, you're not going to, because I have some tricks. Anyway, so there's a computer club. Oh my goodness. Get out of here. All right, so there's a computer club here in Madison called Kids Code. And as kind of an exercise in teaching them what brute forcing was, I made them this little website called Hack Me. And oh, is it sending me a push notification? That's what it is. Off to a rocky start. All right, there we go. I'm connected. All right. So what was I saying? Okay, so as part of like an exercise of teaching kids like what brute forcing was, I made this little Flask application that all it does is just presents a login form, and then what the kids are supposed to like interview me and like fish for information, like ask me like where I grew up, like what my favorite sports teams are, and then use that information to guess the password. And there's a login form. Actually, how about I just run it? Let's do that. So I'm going to. There we go. So kick it off. So it's basically just a login form, and you try to guess the password, and it says, sorry, test is not the password. And when you get it right, you're greeted by this. Sorry about the white screen, but yeah, the password is Blackhawks. I grew up in Illinois, so that's what they were supposed to find out from me with social engineering. Although it doesn't take much, because everybody who grew up in Illinois won't stop talking about the Blackhawks. Anyway, so I'll show you the code for that. It's pretty simple. Very small website. So there's no database or anything. You can do a lot of stuff with Flask, but this is about it. I mean, it's like one controller. You post the password, which is just stored in a base64 encoded string here. And funny story, it wasn't base64 encoded when when we started the lesson, and one of the kids got the password in like 5 minutes. And I was like, how did you do that? And I saw him, he was on my GitHub, so. I had to buy him a chocolate chip muffin. And yeah. You can't even teach hackers how to hack without somebody hacking the lesson. Anyway. Yes, it is. But luckily, there's nothing important behind the password other than that GIF. So anyway, so here's the controller. You post to it. It checks to see if the password is correct, and then kicks you over to that page. And what the kids were supposed to do is like use Python to kind of feed in passwords. And the goal was, the kids who were like tenacious enough to use code to guess passwords more quickly and get a feedback cycle going, usually ended up guessing the password quickly. So anyway, that's probably the most Python you're going to see in this demo. So that's the big twist. We're not going to be writing Python together. We're going to kind of take this app and get it into Amazon. That's kind of the goal of this talk. As a cloud engineer, I have a lot of experience building stuff in the cloud, and to a Python community, the thing that I'm going to try to bring is like, what this is kind of written for is like maybe you have like a Flask application sitting on your desktop, and it's really complicated, and it can do all this stuff, and it can deliver value, but you don't really know how to like get it up into Amazon. Like maybe it's running on a server, but you're just kind of watching this whole AWS thing go by, and you don't know where to start. So hopefully in this talk, we're going to ease into Amazon. We're going to kind of dip our toes in, do the bare minimum just to like technically get it up in Amazon. And then hopefully as we flesh things out, we'll get to you know, full blown like wearing Amazon t-shirts, managed services. It'll turn into a big Amazon commercial. Anyway, so that's the example application we're going to set up. Let's start writing code. And standard disclaimers. So to run this stuff, you need an Amazon account. And when you build stuff in Amazon, it costs money. So I guess all I have to say is like, don't run this code and then send me a bill for what you made. I'll try to call out stuff that's like, you know, costs money, because I'm kind of a cheapskate myself. So like I keep that in the back of my head, like, okay, what do I need to tear down after 5 minutes when I'm done playing with it? So Amazon bills me like 3 cents. But anyway, I'll call that out. And yeah, secondly, like I mentioned, it's all going to be on GitHub too. So I'm going to create a repository called Madpy. And can everybody see my font? Am I big enough? All right, cool. And then we're going to kind of first do like a hello world in Terraform, but it's going to be more like a hello Amazon. So with Terraform, you can like, there's a bunch of different ways to organize things, but my patented trusty method is just putting everything in one file. So that's going to be good enough for us. And to set up an Amazon backend, just looks like that. So, but we're already kind of at a crossroads here, because the Terraform provider for Amazon requires a region. So, oh yeah. How's that? Good? Thank you. Okay, so we're already kind of a decision here. So when building an Amazon, you have to pick a region. It's really not important. Like they are actual regions. The one I'm choosing now is Ohio, but you can build in Hong Kong, Mumbai, anything you want. But I'm going to build in Ohio because it's the most closest. So we're going to give it US East 2. And then a hello world in Terraform. We'll get out of that. It's going to look like this. You run Terraform init. It's going to download the providers you need. So it already picked up that I'm using Amazon. And then I'm going to make sure that my credentials are set. I'm sorry. Terraform is, it's hard to explain now that I think of it. It's basically like an infrastructure as code language or framework. So you write all your infrastructure in like the same language, and you can hook it up to like, okay, here are the resources I want in Amazon. You can declare them. You can, you know, do DigitalOcean, wherever else you may have your infrastructure like scattered around. And then you get to keep it all in one place. So I guess maybe it'll make more sense if I just, you know, show you. Infrastructure, I'm thinking of kind of like what you do on like DigitalOcean by just like clicking around. Like when you launch a droplet, you get like a VM and it gives you like an IP address and you can log into it. So, you know, anything that you need to like get your code running for the public. So pretty, yeah, in the back. Yeah, so yeah, you can think of it like that. So you can kind of like control what you're doing in Amazon, you know, without having to actually like click around a website. So yeah, good questions. Sorry, I just kind of jumped into things. Anyway, so where are we? So we're going to run Terraform apply. And that worked because we're not really declaring anything. But we're going to add stuff to that in a minute. So phase one of getting our web app into Amazon is basically get it to the equivalent of where it's like a more basic cloud provider where we can just like launch an instance. The bummer is like Amazon doesn't really give you the networks and stuff. So like you kind of arrive at the console and you're like, oh, okay, where do I start? And they're like, all right, you have to build everything. So the best way to do that is definitely with like the console. But I'm gonna cheat here. Have you ever seen like a celebrity chef on TV like take a whole ham and like put it in the oven and then 5 seconds later they take it out and look everybody? I'm gonna do that real quick. So I'm going to go into my secret Terraform bag. and paste in networks, and try to ignore that for now, because I'll explain. Apply. It takes a while to apply, so I'm just going to get it going. Okay, so the best way to like get a, so if you're like new to Amazon, networking is a pretty like terrible place to start. So probably the best way to like just get the bare minimum is to just go to the VPC section of the Amazon console and then launch this VPC wizard. So, I mean, within this thing, like Amazon knows how to create like, you can create a VPC, which is basically like a virtual cloud where all your stuff lives. You can have subnets in there, things where like when you launch something here, it's got a private IP. Anyway, so that's probably the most recommended way to do it. But I just had this magical snippet that I crafted ahead of time. But let me tell you about what we're going to be building. So the networking-wise, we have our virtual cloud, which is just like a data center. And then we have a couple of subnets. So I have 2 public subnets where when I launch something there, they're going to get 2 IP addresses. One that we can hit from like our laptops in this room, which we'll need because if we're making a website, it's got to be public. And then we're going to have a private subnet where hopefully we can have like our, our app workers and things like that in there. So this is all defined here. If you do like get more into Amazon stuff, this is good stuff to like go through on your own time, but obviously it's a terrible place to start. There's kind of a lot of stuff going on here. But yeah, you just, like you remember, have you ever like taken a Java 101 class and like you don't know how to code and you're expecting them to teach you and they're like, all right, first type public static main string. And you're like, what am I typing? This is kind of like the magical incantation we just got to get through. So we're building that. That takes a while. So like I said, we're going to have like some subnets in here. The very last thing is like a security group, which is like a managed Amazon firewall rule. Any security people in this room besides Dave and Niergarth? All right, any decent security person should look at this and kind of cringe because it's really not, it's just allowing everything. So the security, the rule here is just let me talk to everything. And that's, if you do this in production, you probably want to tighten that down a little bit. Like, I mean, you don't, if you're just running a website, you don't need every single port open to the public. But, that's, I've done too many demos that got ruined by security group rules. So I'm not going to let that happen again. All right, so that's all created. And so now after we sort of run the magical snippet that you can find on GitHub later, we have what we need to just launch a VM, which is what we're all about. So we're going to go to the EC2 tab. And then again, this is like if you're used to working with something like a little more pared down like DigitalOcean, this is kind of like we're just launching a droplet. So I'm going to click on here, go to this wizard, and then I'm going to pick Ubuntu. It says like which distro do you want to use, like the size. And this is kind of like we're sort of doing anti-DevOps right now. We're clicking around, but when I write infrastructure as code, I don't like to just like stick to the code. I like to run the code and then flip over to the console and then see what it made. And that's probably a good way to do Amazon because like you don't want to just, you want to see what you're doing. All right, so we have our Madpy VPC we created here. We're going to put it in the public subnet because we want to be able to hit it. So you can see we have our 4 subnets. 2 of them are, I'm just going to pick the first one. And then I think that's all good on this screen. It feels like I'm installing something on Windows, doesn't it? So we're going to throw a tag on there. You should definitely use tags when you're building stuff in Amazon, just to like keep track of where everything is. I'm going to call it Madpy app. And then we're going to pick our farce of a security group that we made. This is all stuff that was just written by code now. So, all right, and I think we're all ready to launch. So the last step, I'm going to give it my SSH key, which I had there ahead of time. And kind of like any other cloud provider, like when it launches a VM, SSH is going to already be running, and it's going to have an SSH key ready for you. So we'll be able to get to it. So we're going to launch that. And that should be coming up here. Yeah.
So that step theoretically could be just another block in a term.
Mm-hmm. Yeah. So we're kind of like the goal is infrastructure as code, but I like to kind of like mix things up by do some of it by hand, and then once I figure out how to actually do it, I scale it back and I do that in code. So that's what I'm hoping to do today. All right. So that's up and running, and then now we're going to SSH to it. So we're going to go public IP, and then there we go. So we're on an Ubuntu box. Everybody see that? And then, okay, so what kinds of stuff would we do if we wanted to just like deploy a Flask app out in the wild? Anybody know where we get started? Gotta install Python. I think Python's already installed, so we're good there. But we do have some pip packages to install, so let's grab pip. And the Ubuntu is kind of handling the Python 3 transition a little awkward because it's all the same packages. It just starts at Python 3. So we're going to install Python 3 pip. Apps get update. That's going to pull down a bunch of stuff. All right, so we're going to install pip. What else do we need to do? We need to do what? Pip environment. We could do that. To avoid that, I put a requirements.txt file in my repo, so that'll probably work for our purposes. But we need to clone the source code, right? So we're gonna let that install. All right, cool. I'm gonna go to root. So we're gonna clone my little Hackney repo, github.com. And then we're just gonna clone it to /app, pull that down. And then we could use pipenv here, but like I said, to avoid all that, I just have a requirements.txt file in the repo. So we're going to install what's in there. We want pip3. I always forget. I practiced this like 100 times, and of course I'm making all the typos now. All right, so then how do we launch a Flask app? It's Python 3 server pi. And then there we go. So the app is running. So theoretically, because we launched our VM in like a public subnet, and it's got an IP address, the same IP that I used to log into it, we should be able to hit the website. All right. So all pretty good, but it felt a little manual. Like I thought Amazon was supposed to be automated. Why is this guy logging into stuff and installing packages? I can do that without Amazon. So much like Pierce kind of hinted at, foreshadowing, we're going to do the whole thing with code. So hopefully by the time we edit the code, we're going to apply it, and that's going to do all that automatically for us. So, we excited? We're kind of excited. I think you could hit it from this room if you want. It's 18.188.31.1. It's running on port 5000. Don't write that down because I'm about to destroy this. All right, so it's gone because we're going to build one with code, and then I'll give you that IP address. Okay, so the best way to the best way to write Terraform is using old programming wisdom. You Google it. So here's how I go about things. I just go Terraform EC2 instance, and the Terraform docs are absolutely fantastic. They're very SEO friendly. They're always the first Google result. And then there you go. So this is kind of Terraform explaining to you how to provision an EC2 instance. I'm going to Google the first one and like show you where the docs are. I have all these in my magic code bag that I'll just pull out in the future. But let's do the first one. The contemplative way. All right. So this is the actual thing that declares the EC2 instance here. So we're going to start off with that. We're going to paste that in there. We're going to call ours app because that's kind of the name that we've been using. We want an instance type, T2 micro. That's good because it's the cheapest. And then we're going to give it a name so we can keep track of things. And then what else do we need? We need to give it a subnet. So I think I saw a subnet in here. Okay, so subnet ID. All right, I think I'm going to cheat. Is that okay? There we go. And all that stuff I just magically got there. All right, so okay, so basically what we need to define a subnet is the same things that I clicked on in the console. So this is kind of like it's going to be exactly what we did in the console, except just in code. And it's much faster. The subnet ID, we're going to want to grab the subnet we made. I should have had that at the ready. See. So we're going to put it in the public one so we can hit it. And then there's the ID. That's a key name. And then we're going to give it my SSH key. We won't really need to log into it because hopefully it'll just do what it needs to do automatically. And then we're going to give it our security group here. And again, the security group is kind of a sham. You don't really need it now, but just in case you use the code to build something, I want all the references to be there. And then, yeah. Oh, yeah. And actually, I usually run this, and then I hit an error, so thanks for reminding me. But okay, so the AMI is kind of Amazon's term. I don't remember what it stands for, but it basically means like, remember that screen that was like, what distro are we going to use? And I picked Ubuntu. What that pulled in was an AMI ID, which is a kind of Amazon's identifier for the distros that are out there for you to use in your VM. They're really just like snapshots of disks. But anyway, so we can't really do that with Terraform. We can't like click on a wizard. But what we can do, as kind of alluded in the docs, is we can pull that value down with this data resolver. So I have one of those here. You can kind of think of it like a SQL query where it has like all the filters it looks like. It's like, okay, find the AMI published by Canonical from their Amazon account. It's very weird. And then, pull it down. It should match the name like Ubuntu 1804. But that looks like this. There you go. So it's going to grab the most recent AMI matching this naming convention. Basically, almost exactly what it says in the docs here, except they just changed it from 1404 to 1804. But, and then, so the last part is we can build the instance with code, but who's going to run all the commands on it? Do we have to run that ourselves? No, we don't. Of course not. It's Amazon. So I'd like to draw your attention to an attribute here called user data. It's a really weird term, but according to the docs, user data is to provide when launching the instance. I guess it's not as helpful as I thought it'd be. But the user data for an instance is kind of it's basically a lot like a Docker run command. Like it's like, okay, once I come up, what am I supposed to do? And it's literally just a shell script. So if we want our instance to do everything we did manually, we can just give it all the commands that I ran. So we're gonna do that like this. We're gonna go to user data. We're gonna create one of these so we don't have to fit it all on one string. So we can see. And then we're gonna give it one of these. And then, so does anybody remember the steps that we had to take to install the app? And then we had to install pip. And then we had to clone the repo. And actually, I don't need sudo here because I think it runs as root. I think Ubuntu is polite enough to not make you feel like an idiot, though. It'll still work, which is nice. All right, so we're going to clone hackme to the app. And then what was the last thing we did? So we're going to install. So we're basically just writing a script to control how the instance launches. Requirements.txt. Yeah. Then we got to launch it. I have a room full of typo checkers. All right. So if everything went according to plan, we should be able to run this, and then everything that I did by hand, it should just work. We're going to run apply.
Can you explain what apply does, like incrementally comparing what's there?
Good question. So apply is basically what it's, so Terraform is tracking state. It has a concept of like what you last created. So when you run apply, it's going to first like figure out what's already there and then figure out what you added to code and then kind of present you with a diff. And then when you type yes, like it did up here, that's when it goes out and like syncs it up. So it takes your code, everything that you provisioned out, and then it actually just, make it so. Right? So if we flip over to the console, and then here's why tags are important, because if you're using your work Amazon account, there's a bunch of crap here. We're going to filter by Madpy, and then there we go. It's already up. So I was hoping to be able to log into it, and then we can actually see the commands while they run, which is a cool trick. Let's see if we can make it. There it is. So that's the same output from the script that we typed earlier, except now the instance just knows how to do it. So theoretically, I didn't really need to log in, but I don't know, I think it's neat, right? So it's installing the packages. What's it got to do next? Pip? Anybody have any questions while we wait for this to finish? Or yeah.
So, Amazon is great. I know Terraform works for we have to change a lot of
You could use Azure. Terraform definitely works with Azure. The code probably won't look the same because like when you look at like what makes up a Terraform resource, it's pretty bare bones. Like these options are going to be kind of Amazon specific. But yeah, there's you can definitely do like as far as just infrastructure as code. There's probably an Azure way of like spinning up a VM and like assigning it to a subnet. But yeah, definitely not limited to Amazon. And the cool thing about Terraform is you can even use a little bit of both. So if for some weird reason your company is in both Amazon and Azure, you can kind of, glue it together.
Or what we deal with is we have some stuff in Amazon and then there's some Cloudflare. So it's shuffling up pieces.
And there we go. So yeah, pretty cool. Again, we're kind of taking baby steps here. So we kind of we created a VPC, we launched it by hand, logged into it, and then this is a way to do that kind of automatically. So let's check our time. We're at 26 minutes, so I think we'll have time to, do we want to throw a load balancer in front of it? That'd be fun. All right, let's do it. All right, so so we have our instance, it's up and running, but it would be kind of nice if we had some like separation, right? We have like these private subnets that are, very restricted to just like our little data set that we created. It'd be sweet if we could like run the Flask app behind that private subnet and then just access it with another instance in the public. So that way we have some separation of concerns, right? You have like your edge, the DMZ, and then the private subnet. So we could spin up another instance that just runs Nginx and point it and log into it and configure it and all that stuff. Or we could just use an Amazon load balancer, which is what we're going to do today. So we're going to tear. Actually, we'll leave that up. We'll let Terraform move it for us. I'm going to reach into my snippet bag. So again, if I were just doing this the first time, I would just Google Terraform load balancer, and then it kind of just walks you through like how to declare the resource, assign it to the values, and then. So we're going to drop. It's called an ALB, stands for Application Load Balancer. Amazon acronyms are kind of a struggle. I still wrestle with. I don't even know what that one I know, but most of them I don't know what they stand for. I don't know. You just kind of develop your own system, right? Anyway, so this is a load balancer. There's not a lot going on here, but we do need to copy our security groups over. So we're going to throw that in there.
Security group is packet firewall. So it just says which ports it will allow in.
Yep, that's our managed firewall. And then, so the cool thing about load balancers is you give them two subnets because it kind of knows to like occupy both of them. So behind the scenes, it's going to spin up, one load balancer instance in your first subnet and then one in your second. That's why I spun up two subnets. But that's the cool thing. So we're going to use Terraform to reference what we made. Let's give it our first subnet and our second. And then, like everything else, we're going to name it. Madpy app LB. And then, so the two other things we need to configure for a load balancer, we kind of have to configure both sides of it. There's we need to tell a load balancer what to do with incoming traffic from the public internet, and then we have to tell it what to do with it, like where to send it to the private space. The public side is called the listener, and that looks like this. Pretty simple, not a lot going on here. in fact, we can just move on to the private side, which is called the targeting group. It's basically like, okay, I have this traffic, what do I target? And like this isn't like, it's not really like a networking term, it's kind of just made up by Amazon, but that's what they call it. So we're going to give it a targeting group. And if we look, this kind of makes a little bit more sense. We're going to, so when we get our public traffic, we're going to send it to this private IP from the instance that we created on port 5000. That's about it. And then the last thing we have to do is we have to move our instance to the private subnet. Sorry. We're going to do that like this. We're going to move it to private A.
So that means you won't be able to get directly to the instance.
Exactly. Actually, we don't even need our SSH key. So this is the business we call this Jeff Bezos take the wheel. Nobody's ever said that. All right, so if everything went according to plan, when we spin that up, we don't need to hit our website with the actual VM's IP address anymore. We can go through a load balancer, which gives us a little more decoupling, you know, because our Flask application isn't like right on the edge. Flask is great, but it's you're probably not supposed to run it that way in production. Anyway, so we're going to do Terraform apply, which is take everything in my code and send it up to Amazon. I forgot to use my credentials. All right. So in our change set here, we should see, along with creating our new load balancer, which is, you can see all that stuff here. You get the listener, the target group. It's also going to move our instance. Well, it's not going to let me scroll. It's also going to move our instance to the other subnet, which will destroy it. So anyway, that'll take a minute.
Does that mean that the Terraform, like config is idempotent, sort of run it? So if there's no changes, it's not going to do anything.
Mm-hmm. Yeah. So it's already shutting down our the second VM we created. And if I hit refresh, so another one's already coming up in its place. And then along with the instance that is coming up, we should also have a load balancer here. And then, so the load balancer, like I said, it's basically like I don't know what it runs on the back end. I think it's like HA proxy, but it's kind of a managed version of that. So you don't really have to log in and configure and make sure HA proxy is running. You can just hand it another Amazon resource and say like, okay, you're a load balancer, point all traffic at here in this port. So in the back, yeah. You can, yeah, absolutely. Like you can see here, when this eventually comes up, you'll see like it's just only one attachment. So you can hand it like a whole bunch of IP addresses to forward traffic to, or you can even just hand it something called like an auto scaling group. So you can even kind of like make it further abstract and say like, okay, I don't even care what IP it is. Whatever IP this group of instances comes up with, add them to the traffic. So that should be coming up here. And I think once our load balancer comes up and we can hit it, then we'll declare victory. There we go. All right. So, like you kind of alluded to in the back, we only have one listener on the load balancer, but we can attach like multiple. And you can see there's an IP address. That's our private instance that came up. And then, if we go back to that DNS name, we should be able to hit our website. There we go. Fun, huh? All right, so the benefit of putting it behind a load balancer, we get more separation It's a little more private. We don't need to keep our app worker on the public subnet where it can be like, hit by attackers and stuff. So it's less to monitor. And also, load balancers are cool because they can scale automatically. So if all of a sudden, like your poor little Flask instance gets bombarded with tons of traffic, Amazon, because there's a load balancer in front of it, it can kind of buffer it for you. Eventually, it's going to like back up with traffic, and you'll kind of have to deal with that behind the load balancer. But at least you don't have to like log into the box and like wait for the SSH prompt to take 10 minutes because it's just being buried. Anyway, I've kind of lost track of time, but it's 7:09. I guess I'll leave it up to the MC. We want to declare victory here, or?
Yeah, are there any questions?
I think in closing, I'll kind of give a teaser at what I hadn't planned that
There's
didn't.
a question up there.
Oh, yeah. It's probably not. That's what I do. I'm just like playing around with something. Like if I would just want to like figure out how a new Amazon service works. But what they probably encourage you to do is break things down into like separate files. But the nice thing about Terraform is that like you don't have to. I don't like it when like organizations like force on me. I like when I can kind of grow into it. So but yeah. And I guess if like I said, all the code's on GitHub. So if you want to get to the stuff that we didn't have time for.
Like the Terraform can would take an argument.
Not even. It just Terraform just looks for any .tf file you have like in your repository. So like you can nest it however you want, and yeah, it's cool stuff. So if you want, you can check out the commits I have here. It kind of represents like each stage, starting with like the first one where we just literally said hello to Amazon, and then if you go all the way to the very end in the final version, we can figure out how to put our app instance in an auto-scaling group so it knows how to like spawn instances as we need them. So like if the load balancer backs up with traffic, it can say like, hey, I need 8 more app nodes, and then they just come up. So it's kind of exciting to watch all these automations take over. But anyway, that's what I got.